So this example is going to show you how to use hardware COSIM with ChipScope, which is very convenient. So you can open the serial ISE example, and this one is with the ChipScope's cores already inserted for you. So the ChipScope cores, if you look in the project file, have been inserted into the serial register interface section. And the main difference here, the one critical thing, is the icon core. When you configure it in ChipScope, what you'll have to do is the boundary scan chain must be set to anything but user 1. So user 2, user 3, or user 4. I'm using user 2 here. Then hit generate. User 1 will be used by the hardware COSIM automatically. So once you have this all set up, as before, we just run the simulate behavioral model. So I've already configured the hardware COSIM with everything it needs. There'll be more details on how to set up this serial example in the other video showing you specifically about the serial example. I'm just trying to show you about ChipScope in this video. So when I run simulate, so I clicked on the wrong module here. This is actually an interesting point, and it'll tell you that you've done something wrong and pop up a window, so you can just close that. So you want to simulate the test bench, which uses that. So while that's running, I'm just going to open ChipScope. On the side here, so there's the ChipScope window. And what we have to do is we have to first wait for ISIM, so all this stuff to finish, and then the ISIM window to pop up. So there's some instructions on either in the article or on the programmablelogicinpractice.com website that tell you the specific commands you need to use to get this whole thing to work together. And this is what I've found works pretty reliably. So again, we wait for the synthesis to complete. If you've seen the FFT example where it takes like 15 minutes to synthesize, you'll see this one is much faster, again, because it's obviously a smaller design, so it fits better. So basically what we're going to have to do is once ISIM starts, it starts running the program, we have to restart it, which will stop it communicating. At this point, we have to go over to ChipScope and then connect through the JTAG cable. The thing is here we need to share the cable between these two devices. Once ChipScope is connected, you can then run some commands within ISIM to tell it to share the cable. So it's a bit convoluted because you have to start with ChipScope disconnected, or I find sometimes it fails out completely if ISIM is unable to connect right away. Let ISIM connect, disconnect ISIM, connect ChipScope, set ISIM up to share the cable with ChipScope, and then connect ISIM. So let's see how this is doing. So there we go. That just finished synthesizing, so it pops up ISIM. And again, it's automatically, you can see here, downloading bitstream, blah, 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 blah. So we hit reset, which seems to release everything. We go over to ChipScope, and now we connect to the JTAG cable. And in this case, I'm using the Lx9, the built-in JTAG cable, so this is the Digilent cable. It'll find the ChipScope cores. All right, things look good. And let's just give one of these a name. So this is the TXD line, and you can just look in the code. You can see these, and this is, I believe, the data. Data bus here, and what's the final one? Data ready. This is data ready. So we just rename them. Okay, so you can see ChipScope's connected. So now what we need to do is ISIM is no longer connected, so we actually have to tell to share the cable with ChipScope. So we use this scope command, and it's scope, and you need to know the instance name. So in this case, it's this Lx9 Example _TB. So Lx9 Example _TB/UUT, unit under test. And this is whatever your hardware cosim instance is called. So there you can see it highlighted, Lx9 Example TB/UUT. In the article, I just call it TB/UUT. Obviously, it depends on your exact case, what you called it. So we run that, and then we set hardware cosim command, set the share cable variable, and you set it to 1. So now what we need to do is we need to be able to start debugging, but hit a breakpoint right away. So we'll open the test bench, and we'll actually set a breakpoint, right before it does anything. So just somewhere here. Doesn't really matter. Where will it set one? There we go. Toggle breakpoint. And finally, we hit play. So now it plays. So it downloads the bit stream and pauses. We can now go back to ChipScope, and you can confirm that, hey, it's still working. So it's working with both devices. And finally, you can trigger. You can see my first article in Circuit Seller, which talks a lot more about how to use ChipScope properly. Let's just put it to 1 when it gets a new piece of data. So you could look down here and say that, when data ready is 1, it triggers. So we'll just tell that to go. And then finally I hit play on the test bench. So this particular example, and again you can see the serial port example for more details, is just going to wait for me to hit a button. It sends ABC. ChipScope hasn't triggered yet because I haven't sent any data in. So let's see if we can fit this all in here. And I'm going to send back, some character, DEF. And you'll see that, hey, this triggered because it got new data. And the iSIM hardware cosim is working. So it's going through the physical serial port. I'm capturing data at whatever the hardware rate is running using ChipScope, and then I have the whole thing controlled by hardware cosim. So that's how you can integrate all of these tools together for a sort of more useful debugging process on these FPGAs. So this is there's a total of 4 videos showing you the various things you can do with hardware cosim. Check them all out, and check out my article in Circuit Seller, December 2013.